All right, folks. So I think we can go ahead and get started. Let me go ahead and share my screen. Um, yeah, I'm always delighted to find with Zoom that I'm not as good as I used to be during COVID, but perhaps that's a good thing. More in-person meetings. All right, let's see. Let's do this one. This one looks good. There we go. Perfect. That's fascinating. Something new there. Hmm. Sorry, actually, I just changed my mind about how I wanted to do my screens. I'm so sorry. One second. All right, let me switch back to that PowerPoint presentation. It's so fascinating. All right, let's try it again. Yeah, I'm just trying to get it on. Let's do monitor 3, maybe. How those are going. Well, we're just going to try our best. There we go. But not our best like that. All right, we'll do like that. All right, we've made it past the PowerPoint screen moment, so I guess we can go ahead and get started. All right, welcome everyone. Welcome back to our 4th week of our AI summer. It's been great having you thus far, and I'm glad you're back to join us. Today we are going to, and this week we are going to talk about agentic systems, as you can see here. And let me make sure now that we are seeing the right screen. Great. Um, we have talked about a number of things this week. And in this last, in over our month period, we've talked about how we can use actually these agentic systems, right, to help us with programming. We've talked about the different kinds of models. We've talked about how generative AI models are trained. We've talked about how that evolves into reasoning models. We've talked about about additional steps of training, and also the foundational kinds of training with reinforcement learning. And we have talked about how we then can use these LLMs in platforms like LangChain and LangGraph so that we can create these systems that are able to actually do work for us. So today we're going to move that forward even more. And what we're going to be talking about more in depth is our actual agentic systems. As I sort of alluded to in the beginning, that first week, we were already sort of in the realm of agentic systems, right? We were talking about using platforms like Cursor, using platforms like Replit, where you actually give a prompt about what you want done, something at a pretty high level. And then you see that the agent starts like doing things like this LLM system starts creating this or writing this piece of code, or maybe searching the web or looking at this API. That is the root of what we're going to try to get to actually today. How are these systems working? What do they do? What are they composed of? What makes them tick? And on Friday, we're going to relate all of that closer to what we learned to the rest of the summer. So before we get all the way in, I want to start by asking you if you have any questions. And let me go ahead and pull out my chat so I can see that. Great. And as always, feel free to unmute yourself if you have any questions. Feel free to drop your questions in the chat and I'll try to monitor that just so we can make sure that you get the experience that you're looking for. So also the thing to know about me is I do like to fire hose people. And what does that mean? So like there's this saying about you're just trying to get a little sip of water and then here somebody comes with a fire hose and they're like, this is how you're going to get your drink of water. And so that is me, unfortunately. So you'll probably learn a little bit too much today, but luckily this is recorded. And so you'll be able to go back and visit the recording to catch up on things that maybe you want to hear one more time. So again, any questions before the fire hose begins? All right, awesome. So as you know, we have said the word agentic probably a bunch of times, even during this AI summer, which is just 4 weeks, right? And I'm sure you've heard a lot of just the general buzz in this buzzword about agentic AI. So it used to be that it was just straight like GPT 3.5 turbo or the straight LLM or blah, 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 blah. But now we're hearing that term of agentic AI over and over and over. Here is just a few quick headlines and articles that are just quick search offline from publishers such as New York Times, Forbes, Harvard Business Review, talking about agentic AI. And you'll see with most of the dates that which were published, like they're pretty recent, but also they're going back a little bit further. So we can already see last year, people were saying, okay, well, we see that agentic AI is coming. We might not be there like in this particular moment, but it looks like this is something that's going to be really helpful in businesses, in education, in whatever use case that you have. It looks like this is coming. And so even now we're seeing these new platforms being completely just like built to support agentic AI. For example, you can see like you can see that Microsoft is unveiling some new agentic platforms. You can see AWS is doing this, making it so that people can really build these agentic systems in a really straightforward, streamlined way, make it easy for them to deploy. Interestingly, we can also see that there's another headline by Forbes, and it's talking about generative AI or agentic AI as the new frontier of generative AI. And so what is this, all this hubbub about? Like, what are we talking about? Like, why is agentic AI like the special thing that is different somehow from generative AI because it's the frontier? Like, what is it? Okay, so what is it? So let's talk about it. So the first thing we might want to think about is what is an agent? So this is like the root word of agentic, right? And so in the spirit of multi-agent systems and how we design them, I would love to ask our audience here, particularly if there are people with backgrounds in psychology or sociology or philosophy, can you talk about what it means for something to have agency or be its own agent? And I'll just give you a second so you can type that in the chat or just unmute yourself and comment. And just a quick pro tip, because I know some people are a little bit more, nervous about maybe being recorded or their names like visible. You can feel free, okay, to keep your camera off. And then you can rename yourself to like anonymous vampire, not that, but anonymous chinchilla or something like that, like you get in Google Docs, and then rename yourself and no one has to know that it's you. So tell me about agency. Tell me about what that means. All right, so we are seeing some really great results or some really great comments in the chat. Someone said self-determinative. Someone else says the ability to independently act and make choices. Like these are great descriptions of what we think of as agency. So we think about some entity being able to make some choice in some scenario. So maybe they have the choice about whether they want the green lollipop or the red lollipop. They have the choice of whether they want to go to to, I don't know, to the grocery store today or tomorrow or the next day or online. They have the ability to look at their current circumstances and think about what it is that they want to do. And so this is what agency is. You're able to interact with your environment, if you will, and then make choices about what you would like to do to move you towards some particular objective. And so whenever I think of agency, really showing my age here a little bit, but I think of these choose your own adventures books. Does anyone remember these books or just want to make me like feel good that I'm just not extra old? Quick thumbs up if you have seen or read even these choose your own adventures books. Oh, yes, yes. So with these books, basically what happens is you would start reading it, right? And you would get to some point where the book would be like, well, this is the current scenario because you're reading like a regular book. And then you get to a decision point where the author has allowed you to make choice A or maybe choice B, maybe even choice C. And so instead of with your regular novels, where really you're just kind of following along about what the character is doing, you're able to sort of insert yourself in the book and have this sort of control over where you want the story to end. And so you can kind of see this even in this image. You can see that there are 39 possible endings here, or 42 possible endings here. Based on your own choice, you get to these different outcomes. Whereas in regular novels that you might read, like that is the story, period. And that's the end of the story. And so this is sort of how you can imagine what LLM interaction is versus what agentic systems are. So with your LLM, you might just you might put in a prompt and then just get out a response because LLMs, as we know, super great generating text in a great way, right? Things that humans like because of their training, things that humans prefer, things that are safe and helpful. All of these things that the LLM is trained for. But when you have agents, you're able to look at the section of the book, right? Based on that information that you have, you make a choice between some narrow set of choices. Maybe they're narrow, maybe they're a little bit wider, but you have some set of choices. And so you're able to control the next place that you get to as well. And then you do this iteratively until you get to one of these 42 possible endings in this particular scenario. Or if you're more like a software agent, you might have any number of possible endings, but in those endings, what your objective is to achieve your goal. Now, this idea of agents is actually like not recent. I was reading an article about this, of course, trying to find some great content to be able to talk to you about today. But I was reading an article about this, and it was saying that, oh, the advent of agents, and this is so new, it's such a new idea, and it's developed in 2023, and da da da. So this is true and false all at the same time. So again, showing my age again, back in the day, when we were kind of thinking about the foundations of agents, there was, I mean, this book is still used like extensively. I actually have it sitting next to me. It's the Russell and Norvig's Artificial Intelligence: A Modern Approach. Great book, talks a lot. I mean, it's clearly called Artificial Intelligence, right? So this is what the book is going to be about. But the idea of an agent is not like something that just sprung up in the 2020s, right? This is a pretty old idea about something that you want to really kind of do something. So it's not just like something that only perceives and then does nothing, or just takes sort of like actually there are agents that do that, but it's a framework in which we can think about and evaluate and build systems that have this concept or this idea of agency associated with them. So this is like a picture, like one of the diagrams, literally figure 2.1 in my very old version of the Russell and Norvig textbook. And it's basically showing what we think about as an agent, right? This is a very broad block diagram. This is really referring more to a robotic agent. But you can see we have an agent. There's like some stuff in here in our agent, and it has some ways that it can like interact with its environment. So it might be able to perceive its environment through something. With an actual physical robot, you might think of that as its sensors. So if you have maybe a vacuum that goes about vacuuming up things on the ground, its sensors might be, you know, a distance sensor or something that's able to identify maybe the grittiness of something or how far it's gone, any sensors that allow it to interact like with its environment. Maybe something to just even know if its vacuum bag, I don't know if they even have that, is full. So then as we are learning about our environment, based on whatever we're doing, so this is a very general idea of agent. Modernly, we think of something as an agent. We think of an agent as something that's trying to achieve some sort of objective. Broadly, this isn't true, but we will think about it this way because this is the kind of modern interpretation, especially in the context in which we're talking about it. But we have this agent that's able to sense its environment based on some criteria, then able to act on that environment to move it towards its desired goal. So again, we're able to perceive our environment. Now, if we are a software agent, right, we're LLM, we don't really have hands. So we're not going to be like moving things unless, you know, someone gives us this ability to move things. But with our software agents, the way that we might sense would be the ability to receive information. Like, for example, if you are trying to give the agent information about a website, you might just provide it all that website text. And then with our actuators, that would be actions that we can take. And so we've already actually seen at some length these agents that we interact with, especially if you're a heavy user of ChatGPT or like you've seen the actions that these agents take, which might be to search the web, for example. It might be to call code interpreter, which would be a Python interpreter, to run some code that it wrote, see the outcome, and that might even be part of the goal-directed behavior we're trying to engage in. So we can see that our agents are interacting with the environment and trying to achieve some sort of objectives by the actions that we're able to take. Now, with agents, there also is this sort of idea that they're mostly going to be trying to do things autonomously. So we tend to really think of agents as like not this very less of a chatbot, more of a, hey, could you do this? And then it goes and does and takes whatever actions that it needs to take in order to do the thing. So that's not to say that there can't be some human part of the loop where the agent maybe asks us something else for us to kind of lead it in the direction that we wanted to go. But mostly we think of agents currently as we kind of tell it some information and then it kind of autonomously like goes and does this task. And this task, we're usually going to think of having more than one step, even though that's not a requirement. So it's less, they tend to be less chatbot-y and more like action oriented. If you want to think about an example of this, you can think about deep research, right? So if you go to deep research or on OpenAI or that capability through Perplexity, you kind of say something to it. It might ask you a question back, but then after that, it's off to the races. It is doing research. It's looking at web pages. It's using its tools, all to try to get to that answer that it's trying to find. So let us just, again, familiarize ourselves with sometimes what these things tend to look like. So this is our friendly OpenAI. And we can see an example here of tool, like when an agent might decide that it needs to do something, or when your system decides that it might need to do something and use an external tool so that it needs to achieve that thing. So let's look at how this looks. We could hop onto OpenAI, but we're just going to look at it like this: creating a sample data set with 30 examples to demonstrate the behavior of a random walk, and then plotting it. And then we also want it to create an image that we can include with our graph and our final report. So here, once you see this, this is the call for a tool, because it said to itself, all right, well, they want me to analyze this data set. So it looks like I need to do some pandas, matplotlib something, and I can write code to do that. After it achieved that, it said to itself, okay, anthropomorphizing. But the next step that it found that it needed to execute is to call another tool, which would be something like DALL-E, or maybe its internal capacity to generate images, depending on the model that it is. And then it generated that model. And then it returned the final result, which is all of those things. And then so we have the report with the graph and with this image that we asked for. So something that we can see is that we asked it to do something. It took like these steps, even though we will talk about this more that we're actually seeing with GPT-4o. But it took these steps to get to the result that we were looking for, and then it provided us those things by calling tools to be able to fulfill that objective. So here you can see this with OpenAI. So even in the free tier, you can see that we have, OpenAI stuff, but you see that we have these additional tools that we're able to utilize for the tasks that we need to achieve. So you saw data analysis just then, where it was writing code to analyze some data. You saw image generation, where it was generating this image because we asked it to. Not voice mode, not file uploads. We haven't seen that yet, but they're missing it. But those are also tools that are available. And even further, this was maybe, I think the screenshot is from maybe a little earlier, but through the API, there are even additional tools, and we have seen even more tools than this. So things like web search, we have absolutely seen that. This is another tool, maybe not in the free tier, but it's definitely another tool that can be used, for example, to execute some tasks. So there are sort of these different ways we might think about agents. We might think about them along this axis of the degree of autonomy that an agent is able to have, or a system is able to have. So we can look at this again, and we saw that. And so looking at this one more time, this is an example of, you see the system deciding that it needs to call this tool. I'm going to actually start this over if I can, because we're asking about the most recent updates on the reality show Southern Charm. And the term recent updates is really, it tends to trigger this behavior of searching the web, because as you know, models are trained up to some point, this information cutoff point, because they need some sort of data, right, to train on, and it has a cutoff point. Past that cutoff point, usually it's going to need to call a tool, because it wouldn't know anything after like 2023, 2024. So here it is using a tool and decided that it needed that tool based on what I said to it to find the additional information that it needs to be able to answer the question. And again, you saw that this thing is trying to choose this tool in order to resolve the task. So this is choicey. It is not a choice, but it's choicey. We can look at something else, which I think you have probably tried. Here we are just asking it again about Southern Charm more generally. You see that it doesn't always choose to use the tool. There it didn't. Why? Because we are not really caring about the most recent thing as we phrased it to the LLM. So there it didn't choose to do that. But here we can also force it to use a tool. So this is a system where we are kind of forcing it to do something. So we've kind of removed its agency, even though this thing is sometimes falling under this idea of agentic AI, because it still uses tools, right? It used a tool to make to resolve this question and execute this task, but it didn't kind of choose to use the tool. We forced it. So although, these systems have these capabilities, there are different ways that we can kind of think about the agency of an agent. When there's low agency, we do tend to use different terms other than agent. But as it becomes more agentic, meaning that we're constraining its choices or ability for it to control to make choices to control the flow of its execution, the more it can do that, we think about those things more as agents. So over here, so on this side, we think about that as less agency. If you think back to our work with LangChain, we can always make something like a knowledge base available to a system, right? So our LLM system, we add our vector store because we want to have access to certain information. And if we don't make the system in such a way that the agent can choose not to use the tool, every single time that it's executing, it's always going to use the knowledge base because that's part of its workflow and it doesn't have a choice. And that is where we see the power of agentic AI, because instead of always using this knowledge base or always using this web search, and we really don't always need to use it, we can make the choice to use the knowledge base when relevant, make the choice to use the tool web search when relevant. Okay, And so this is a little pause that I wanted to talk about briefly about what it means for an LLM in particular to choose to use a tool. I think there are other formulations of what it means to choose to use a tool, right? But in this case, do remember that with LLMs, they go through training. LLMs are trained. They're trained on different and augmented sets and types of data with different tasks, so they'll be able to do the task that you're looking for. One of the stages of training, or one kind of the data sets that is used for training, are these tool use data sets, so that the model will learn to use a tool. So not a tool, but learn the context in which tools are used and how to invoke them. So you can kind of see this here. I wish I could make this a little bit bigger, but here you see actually a part of the whole prompt. And so again, this is training data for the LLM. So when we're training it to use tools, this is how we're training it. So you can see that we have part of a prompt here. We said you're a function calling AI model, and we have these tools that we're going to provide, and they're going to be inside. Interesting. Someone asked a tool about a web search tool. I'll come to that in just a second. Such a good question. Okay. So this is the prompt that we're training with, that you should see that you're going to have some tool information provided between these XML tags. You can use one of them as you'd like to. So then we give it some examples. So here within tools, we have get stock price, the description, we have the parameters. Remember that we have a description, which is get the current stock price. So this thing helps the LLM to know when this is an appropriate time to use this function or this tool. So again, rolling back to what we were trying to say before about always using a knowledge base or always using web search. Like, let's say that I'm the LLM and I get a query, which is like asking me about the newest information about something. I might have been trained to understand that based on the description, if I'm given something in my tool tags that says use web search to learn about newest and greatest things that the user asked for, then this description here is how I might choose or learn to choose when is an appropriate time to use my tool. So here again, in this example that we're training on, we have this tool. I think we have some other tools here. We have some more of the prompt. You can also see where this training occurs within the context of the components of prompts of the model, because you can see that this is actually the system prompt, this whole thing, right? Isn't that interesting? And then also we can see the rest of parts of the actual prompt. So here we also see the part where the user, coming back, sorry. Where the user, so the content here, you see that the role here is the user, and it says, hi, can you tell me the current stock price, blah, blah, blah. And you can see that the training data contains the assistant response that it's supposed to do, which is get stock price with symbol. Okay. So this is how our models are kind of understanding that we should, like, they go through training to understand how they should call tools, why they should call tools, what tool calls look like, and what they should do. So this is something that's trained into the model. So the word choice is kind of a word that requires understanding when you're thinking about agency with LLMs. But we're just gonna say choice because it is a distinction from something that would not even be able to like have this ability, right? Okay. So there is a really great question about how does a web search tool work on the back end? If I understand this question correctly, I think this is kind of almost a question about how are tools working within the context of an LLM. And it's kind of related sort of to this, right? So your LLM is running somewhere, right? It's running on some system. You have a function that kind of looks, it's not right written here, but you tend to have like a function in your application layer that actually implements this function, right? Get current stock price. And what happens is once your LLM decides to execute like a tool, what it outputs is the arguments of what it decided to do. So you see here that it said, so the assistant has this response, hey, we need to call this function called get stop price. And this output here, it needs to be error. And one of the arguments to the function needs to be the symbol. This is something that's received in your application. So you call the LLM. So you put in your prompt to the LLM in your application, the LLM executes and it says, all right, it gives you this response here, which is, hey, like we have this tool that needs to be called. Here's the name, here are the arguments. This is returned to your function, your application, and then your application calls the function. So it's going to, because, and this is like more straightforward, right? Because your LLM has returned you the name of the function. So you can look this up in your functions and return you the arguments to that functions. And so you can execute that whole function and then return that response to the LLM for it to compute on, and then it'll return you the full response to the actual query. So this is how this is generally working. If you're implementing this kind of tool use on your own LLM system or on your own like application system, if you are using the agentic functionality that's associated with like OpenAI through their APIs, I think this is different, where it will actually execute something like a web search or any tool or a web search, a specific set of tools on its own, in its own like container. But I think that's a very narrow number of tools that are very well pre-specified. But again, if you are writing this whole application yourself and you yourself are implementing the function call, what you tend to have is the function already written. So whenever the system or the LLM returns you the function that it wants to call, all you have to do is go find the function, put the arguments in it, call the function. So would it be accurate to say that the model chooses a tool within the constraints of the prompts it's been trained with, what you're showing in the blue shaded area? So similarly to the way that LLMs learn things like tasks, like how to execute certain tasks or how to generally respond, how they learn like semantics, how they learn relationships to concepts. This is similar to how tool use learning is going to work. Because again, this data set is like huge. Yeah. So this is one. And then there are like 2 point, I mean, and this is a particular model. I think this is News Hermes. One of their, what is it? Is that News Research? One of their LLMs. It's just very good. But they are able to behave outside of directly what they've been trained with. So we would expect that if we gave it some function that it had never seen before, that it would still be able to execute the function as appropriate, because because it will understand that the relationship is based on this description. If the user is asking me something that fits this description, then I should use the tool that is associated with that description. And so that's why you can also pass in these custom tools, and it will understand to call a tool that it's never seen before, because it understands that the description describes when it should use just some tool that it's never seen. Oh, good question. Good question. All right, and I'm just gonna pause here for a little second. Any questions? Any questions? That was a very good question. Very good questions. Okay, moving right along. So someone asked about the implementation of the web search tool, like function calling, right? Let us talk about this more with respect to agents. And we're going to kind of get into the innards of how agents are generally working. You have already actually been pretty deep into the innards of how agents are working whenever you designed a system using LangGraph. LangGraph is very like, you describe exactly how you want that agent to function. There are other frameworks where we will explore today that are more like declarative. So you say what you want it to sort of do instead of the description of every part of it to design it so deeply. But we're going to go kind of at a higher level than the LangGraph, but maybe also a lower level. So now we're going to talk about how these things are implemented and how agents are generally working. It's interesting. Oh, that's interesting. Oh, exciting. So now with agents, we might think of an agent as something that is augmenting the capabilities of a large language model. And so sometimes we tend to call those systems context augmented. And what that means, again, is that we have this LLM, right? And so normally we have the LLM. It's been trained in some way, and we just saw like the tasks that it needs to do, instruction fine-tuning, supervised fine-tuning, tool calling. It has been trained on all these things. But even beyond that, it needs more things to act in an agentic way for some tasks. And so to do that, we augment it with some specific capabilities. So we might give it access to some different tools that it needs to use. Maybe we have a special thing that we need this agent to do, like we need it to use our very special enterprise version of blah, 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 blah. And so we need to write a function that does that. Maybe those are the tools that we give it. Or maybe that's one of the tools that we give it. Maybe we need it to be able to read the information from a particular page of a book when all we have is a picture. Maybe we just need it to be able to identify what is in a particular image and locate it on Google Maps. We might provide any of those tools to our system so that it would be able to complete the task. We also have retrieval, which is something that you learned about last week. Retrieval being if you give the system a lot of information, for example. So let's say that you have just thousands and thousands of pages of technical reports that maybe you can't, like you only need specific subsections of any given report to answer a particular question. This would be a great moment for retrieval where your LLM could choose whether it wants to use a retriever, so the thing that actually grabs the information from all of those technical documents, or maybe you have a question that's like, what's the weather today? And so in that case, it might not use that retrieval system. It might use something else. So we give it access to different tools. We give it access to those retrieval systems. We also, for more long-running agents, we might give it access to different kinds of memory, for example. So there's lots of different kinds of memory. One is a sort of short-term memory. So we always have like the conversational history, but then like of that particular conversation that you're having, for example. But what happens if the conversation is like over days and it's like super long? Then what? We might also, we can take that short-term memory, we can condense it, we can store parts of it. There are lots of different options that we have in terms of working with this short-term memory. Maybe if we want to store things about our user or about the many sessions of execution that we've had as an agent, maybe we use a long-term agent. Long-term memory. So what that would suggest is maybe after each conversation, or maybe if we are interacting with different users, they're all trying to achieve the same task, we might store some new information that we didn't know in some database somewhere so that we can call it if needed. Or we might use that information and maybe even just add it into the system prompt because that's something that we want to do. There are different ways of implementing like a long-term memory, how you pull in that information, how you create that information, how you store that information, and how you use that information. So a lot of times we're going to add like this kind of memory into our more agentic long-running systems or systems that we want to be customized for a particular person or set of task. We also have the state, which can reflect some aspects of memory if we want to. So sometimes we might choose to instead have like the short-term memory in the state. We can have, if we did have something that is like something roaming around or something physical, we could store information about its location, for example, or whatever we want to create some information based on in the current state or previous state. So we take our LLM and we give it access to additional things that help it have more resources so that it can achieve the goal that it's trying to do based on the very powerful reasoning and planning and thinking abilities of our LLM. Okay, so now that we have those components available, the agents tend to act in an iterative way to try to get to the solution that you're looking for. So here we can kind of see that we have some requests that we might want to make of our AI system. It might try to ask something of a knowledge base so we can get some additional information. So maybe it's supposed to be an expert in construction. And so maybe you have a database that is about all the specifications for building houses. Maybe you're asking it to help you build a house. And so maybe the first thing that it does is it goes and looks in all that library that you have provided to it, and it figures out, all right, well, these are the parameters that I need to build the house. And so let me put that into my current state or my current context. All right, well, maybe I have a tool that's available to me that maybe, I don't know, maybe it's Google Sketch or something. And so now I can create like this outline of what the house would look like or whatever have you. I get a response from that tool. Maybe I know the user really likes a particular kind of house. And so now I take that into account. And so I give them some sort of, I don't know, construction that reflects a different kind of house, or I put their particular address on like the rendering or whatever have you. And then by doing all those things, sometimes like iteratively. So this can be an iteration and then we try again, or we can do all those things. But whatever we're doing, in the end, we have some response to the user. So we were talking about this just a little bit before, but with our agents, we can have it execute. So the number of steps that the agent needs to take to resolve or come to the goal is not really a determination of whether it's an agent or not. We have some agents that are one step, so we might give it a prompt. So again, we saw the prompt that we trained the model on before, but we'll talk about a different prompt. And so we might give it a prompt. It's just going to call the LLM to do whatever we need to do. Maybe that is like that we just need to execute this tool call. So it'll provide the arguments, the name of the tool. We might execute that tool call and maybe we're done. Like maybe all I said to my agent was, hey, what's the weather today? That's all I need to know. So my agent says, all right, well, she wants to know the weather. Let me use my get weather function. I'm just going to look at the weather channel and I'm going to give her the weather for today. We execute that and then we're done. Awesome. Thanks, agent. Other tasks may require more steps. And then this is the thing that really gives you the power of an agent. So you're not constrained to just this one thing. Maybe what I really asked it is, what should I wear today? And so it might, in trying to resolve what I want to wear today, look as part of its multi-step generation of my clothing choices. It might look at the weather so it can know that I don't need to be wearing snow boots today. I should wear flip-flops or something like this. So this is the really nice part of the multi-step agents, or agents that are able to do multi-step behaviors, because we can have it iterate on what it knows. And as it's interacting with this environment, using that information, pulling it into its context so we can use that for additional steps. So we might have a different kind of prompt. So like this one, you see that this prompt is talking about a thought, action, observation loop. Interesting. We'll get to what that is, but we see that we are now using that memory, or depending how you want to implement it, we're using that memory. We are going to add information. So, I mean, we're going to put the prompt into the LLM, but we're going to, because it's a loop, we're going to start appending things. We'll get back to that. We're going to put this prompt into the LLM. If it calls a tool, great, wonderful. We're going to get that result. If the problem isn't resolved, like that is when we start going to these loops, right? So if the problem is not resolved, that is when we might look at the output of our tool call. So let's say, again, that I'm asking the LLM what to wear. Maybe the first thing that it thinks about is the weather. And so it calls get weather as it normally would. Is the problem solved? Does she know what to wear? Nope. So we're just going to say, all right, the temperature today is blah, 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 blah. We're going to put that back into the LLM with the original prompt. And if it decides to call a tool again, then that's something that it'll do, and it'll iterate until it can identify that the problem has been solved and it has a final answer. So this is a iterative moment where we are adding on information based on our observations. Again, going back to our very original formulation of what an agent is, we are interacting with our software environment, right? What we have access to, and we are updating our current state. based on the observations that we get from our environment. So again, if we're calling our weather function, we're trying to get the weather from the Weather Channel, the observations that we have made of our environment would be the information that we got from the Weather Channel, and those are the things that we're adding onto our memory or adding into our state, so we can use that on the next iteration to think about what we need to do or the next steps that we need to take. So when we're thinking about agents, what we really think about is an implementation that looks a lot like this, where what we really have is something very loopy, right? It's a loop where we're always like, we exit the loop on the, so we continue while we haven't resolved the task, right? And so that's based on what we are kind of looking at in our iterative building up of state or of memory or of what we're trying to achieve. And then so based on that information, we take an action. An action really does not have to be a tool call. It can be something else like, let me go ahead and make the summary of something, right? We might take or not take an action based on those actions. We can execute it so we can get the observations of what the result of that was. And then we add that into our memory and we continue until we stop. So this is very, very like loopish. So why did I particularly insert this into the conversation? So when you kind of look at this behavior here, yep, we went too far again, but we might think about some of the reasoning agents that we've seen in the second week, right? And so what we saw were these agents or these reasoning models that we would give them some sort of task and it would appear to iteratively go through these loops. But what you're seeing with the reasoning models is like a very long sort of generation. You might see so things might be taken in and out of context, but what you're seeing is like a very long generation. So it is not doing like this sort of behavior. It's a generation instead based on like tokens. So rolling back, we said that we would talk about this prompt. We're also looking at this React word. What is it? So this is how most of the agents are currently implemented today. And again, keeping in mind the fact that our reasoning models really just sort of came out recently. And so now the field sort of needs to like adapt to the presence of these reasoning models, which are very powerful. And we need to study that more. So if you, it needs empirical sort of exploration. But you can see that we have this React kind of statement. And what is React? It's this framework in which we give an agent the ability to think about what it's going to do and do this thing. And so this is what the React prompt looks like, where we give it the framework, the decision-making framework, so that it can like pursue this outcome. So we tend to think about it as, so this is like reasoning plus action. We sometimes add in the thought part where we force the LLM to outline based on what it sees now, what observations it has about the current observations. Based on that, what should it do next? And then it will generate something like an action. So again, we're thinking about is the name of the function and the arguments. And then we actually execute that. And then we're able to look at the output of that tool call, that function call, whatever we're doing, and decide if we're done. So again, we have like these like steps that we do where we have some input to the LLM. We might or might not take this thought or enforce this thought part on the LLM, but we take an action to use a tool. Now that's added back in. We might take another action. Maybe that requires another tool. We might take another action. And then looking at observing all of our outputs and our context, that we might find that we are finished with this task and output the final response of the LLM. In this example, is the model only going to stop until prompted by the end user confirms that this is such a good question. So the question is basically like, how do these agents know when to stop? When do they stop? So they stop when they have like evaluated that they have found or are able to deliver the final answer. So part of the prompt that we might see is that when the LLM is ready, or when the agentic system is ready to be done with things, it might be prompted to have like a particular like phrase or keyword that it outputs, like final answer. And then once the system sees that final answer, like that set of tokens has been issued, now the system stops because we know that it's done. It said that it had the final answer, and so that's the final answer. So it's done. It's also a really good question because it kind of points to some of the challenges that we had with earlier versions of agents, even with LLMs, because sometimes agents will get like they're just not, they're unable to, or they don't have like the reasoning ability for that particular task that they're trying to carry out to be able to actually like execute the set of steps or think about what steps to execute well so that it ever finishes the task. So it gets in these sort of like logical loops. Maybe we might think about it as like, what is it called? Analysis paralysis, where it's like overthinking so much that it never actually gets to like an output. And so those things absolutely happen to LLMs. And with modern frameworks, you often have like a number of iterations. You're able to set like a maximum number of iterations. So if the LLM can't resolve it by that maximum iterations, like it's not going to keep going for infinity or until your GPU gives out, like there will be a stopping point, and it's that maximum iterations. But this is really something that has been like notable for earlier versions of LLMs because they didn't have the like sort of intellectual power that some of our more recent LLMs have. So there's another question. If you wanted a specifically trained LLM to be a tool, would it also be able to act well as the delegating LLM? Would it need to initiate the tool call as a new state? Oh boy, this is so fascinating. I have such a treat for you to answer that question. But you can absolutely use an LLM as a tool. It is a tool, right? Like you could write a function to call a LLM. And since you're able to write this function, you can give that function to your orchestrator LLM to just be accessible, right? It's just like a tool. It's like, instead of giving it like a hammer, you're going to give it like a sledgehammer or something. And so instead of like call hammer, you're just going to do call sledgehammer. And then you'll have to write a really nice description about why it should use, in the cases in which it should use that particular tool. So yeah, like when you think about tools, like think very, very broadly. If you can write a function, then that thing can be a tool. So just think about that. It's kind of awesome. Okay. Okay. So React framework for decision-making for agents. It has three kind of parts where you have thought, where you figure out, oh boy, oh no, we're going the wrong way. We're going to make it back there. The LLM thinks about what it's supposed to do. It decides on an action to take with the arguments. Then your application is going to execute that tool call, return it to your system, and then your agent is going to look at that, see whether it's completed, maybe issue whatever a special phrase that it's supposed to do to indicate that it's done in the system. And then if it's not done, continue iterating as needed. And sometimes, again, with our React framework, we take out our thought step. So that, because a lot of the more modern LLMs are going to kind of do this anyways, because of the way that they're trained. So hopefully I can take you to this page. Oh. Okay, and so we can look at an actual React prompt. Let me see if I can share that. Nope. Share that right quick. Oh boy, I'll tell you what. I'm so tickled. I used to be so good with Zoom. Let's try to find just the right screen out of 1 million screens. We made it. So here, this is an actual React prompt. You can see this is in a platform called Llama Index. And so you see, I mean, you see how it's nested, right? This is in, so Llama Index is a very like, it's like a different kind of LangChain. So another framework, Python, open source, Also, there's like a sort of an enterprise version of it where it's like they manage it for you, so here or there. Oh, also they have a really great, it's like called Llama Parse, I think. It is really great for if you have really complicated sort of documents and you want to be able to like use them in RAG. So if you have like an image with weird looking tables and then like Llama Parse is really good for this. It is a paid solution, but it probably has free tiers. Anyways, so Llama Index, again, it's a Python framework, kind of like LangChain, but it has, and it has a lot of functionality related to like RAG, loading documents, reading documents, tools, all that great stuff, pre-existing workflows, agent systems. Great, just a different choice. And so here what we can see is, again, super nested into agents, specifically the React kind. And then this is the templates for React, and this would be the system message, right? And so here you see exactly what the system message is. So you're going to help the user do whatever they need to do. You have access to these tools. So again, we see the description again. So we have a description and we have some information that we're going to pass in. We want to tell, so again, this is the system prompt. So system prompt, again, is a very strong guiding behavior of the system, which is why you get this kind of agentic behavior. But anyways, so here we have the output format. So this is going to help the LLM or the agentic system output things in the way that we want it to, specifically the React components. So here you actually see the thought part. So we want, again, one, same language, but two, use the format where we want it to say something like thought, the blah, 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 and I need a tool to help me answer the question. We want it to say for the action that the tool name is blah, 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 blah. If it uses the tool, what the input is to that tool that we see here. You can see some actions there. We give it some more information about what we really want it to do. Somebody was asking about the final, like when it stops, right? So when it repeats the above until it has enough information to answer the question without using any more tools, at that point, you must respond in one of the following two formats, right? And so here you're seeing like the ending criteria. You can imagine that there is probably some loop ending kind of like code that looks for either these two things together or just this answer term. It'd be better probably if they did these two things together. But we see that it needs to be either this or this. Also, you see why we can sometimes get into these like loops that are infinite, especially with earlier models that weren't always just the best at following instructions. Maybe it finally finished and it like did a great job, but then it said final answer, or well, final answer, which might break the code for it to stop, or this, or these kinds of different things. So here are like the stopping criteria where the final answer is thought. I can answer blah, blah, blah with the answer, or I cannot, da, 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 and then here is the answer. And then they also add in the current conversation with the observations in that grade set. So this is the actual React prompt that they are using in Llama Index. And you can kind of see, again, where we are asking for the system to give us some more information on its decision-making, right? And so I know that there is concern, ongoing concern about why LLMs or why agents make certain choices. People want to know, like, what was the information that led to this outcome? This is kind of providing some insight into that. So you're not completely blind about the situation, why it made certain choices. You're able to read that in often something called the agent scratchpad, or a lot of the settings that you have will allow your LLM to be like verbose and output this information so you can read through it and understand like why it has done the things that it's done. We also have access to other observability platforms, which would log this information into some backend log, which are incredibly helpful. Okay. Now switching back, because I am an expert at that. All right, coming back to this. Oh, I didn't even have to switch back. So based on that, okay, pretty exciting times. Based on that, we can begin exploring one of my favorite frameworks, for AI systems because it is very declarative. You basically say the things that you want You do like you probably have a little bit more depth than like just saying exactly what you want. But the way that you specify how the agent should behave is at a much higher level than having to like kind of detail every single little like piece. So let us take maybe a little 10-minute break. We'll come back in 10 minutes, so like 12:11. And then we will start talking about CrewAI because it's super cool. Okay, so 10-minute break, 12:11, and we'll be back here. And I'll see you in 10. All right, and I think that we are back. All right, so let's just jump right in. So what we ended with was that we were going to now explore a particularly nice platform for agentic systems. So yeah, let's just do that. Before we get all the way up in there, okay? Any questions? Okey doke. Okay, well, let me go ahead and share my screen. We're just gonna have to do desktop 3. There we go. Let's do it. Okay. But also we're gonna have to move this elsewhere. Great. Oh, not that. Okay. So I think right now, maybe you should be able to see, yes, CrewAI. And let me drop that link in the chat. It's really just crewai.com. Slight hazard, if you type in crew.ai, that is a different website, but it will, I think it does link you back to here. So CrewAI, again, this is a platform I really love because I think it really highlights what the kinds of things that we can think about when we are building our agentic systems, okay? So one, you can see lots of things here, just we're looking at it, right? I mean, not only does this have an open source kind of component, right? It also does have this enterprise component. So again, I know some people here are less interested in the building of the system and the more of the, I just want to specify like what this thing is, and then I want an endpoint or a website or something I can access without having to do all this like coding. This is a great platform for this. If you go ahead and actually like create a trial, I think you should be able to do it actually pretty quickly. And it's a pretty interesting experience, pretty cool. But let's go ahead and explore though that open source part. So here, when we click on open source, one, we're already seeing things that we like, right? This is giving you a good intuition about the kinds of things that we expect that we would have to write or we would be looking at. Does this look familiar to anybody? Thought. Using tool. It's giving action. Input. Just giving action input. This is output. This is giving observation. That looks super familiar to something that we were just talking about. So one, we're already sort of knowledgeable about what we would expect the behavior for the system to be, because this is giving the general look. So this would be something that you would see or read from the system, but this is giving like the layout of what you would expect from a React model, right? And so we might expect that that is the foundational behavior of this platform. So here, if we want to, so you can always scroll down, right? Scrolling down is great. You look at docs, really look at docs when you look at them, but there's a lot of things that we will see. I will just like unleash this upon you just to begin with. But as you scroll down, you can see, one, you can see some code here, right? Where we are going to create this crew, whatever that thing means. So we're going to create this crew and we can see sort of how we specify that, right? We specify the LLM because we have a context augmented system, right? So we're augmenting our LLM. So of course we would expect to be able to use a LLM and specify it there. So there goes our LLM. And we might also, because we know this is an agent, we might expect that we would have access to some tools. And also we can see the full definition of the agent. And this is what I really love about Crew. There are other frameworks like this as well. I think OpenAI just released one that is very similar, where you're able to define what you want the agent to be. So it's like a very robust sort of system prompt where you're describing, hey, like this is what the purpose of this agent really is, and we can even like give it this name. This right here, where you see topic, this is a variable. So let's say me, the user, I am specifying some topic like, hey, could you do some research on agents? So agents would be passed into here. So agentic AI, senior researcher, and that would be the role for this particular agent. For this goal, this is again something we as a developer specify. We're saying, hey, the thing that we're trying to achieve, agent, is we want you to uncover these groundbreaking technologies in whatever is defined by the user for this year. We're giving it a backstory. We're telling it how we want it to think about approaching the task, or giving it some more contextualization of how we expect it to behave, right? So these are really the pieces, some of the pieces that I really like about agents, where really this puts the expertise in the hands of developers, or in domain experts, because the domain expert is really able to create really great definitions for the agent that they want to actually execute some task. So they'll be able to give a really great role name that would be familiar to and relevant and well contextualized by the current training data, right? You could give it a goal that is specific to something that you know very, very well about. You can give it a backstory, even about the things that you think about as you're making decisions. So these things here that you see are kind of short, but could be longer to have a more robust definition of what we're looking at. 2, the tasks. So we'll do all this again, but just some things that we're looking at. So 1, we have an agent. So the definition of the goal that we're trying to achieve and the kind of background of that agent that is going to try to achieve that goal. We needed to do stuff, right? What are those things? We've defined tasks, the tasks that we want it to execute and actually take out. Do we define the minutia of those tasks? No. But do we kind of describe what it is that we want? Yes. So we describe the thing that the agent should be doing, where we're identifying the next big trend in that same topic the user passed in with pros and cons. We're just writing that in plain text. We're not writing that in any kind of difficult way. We are just writing the words for this. We are also writing what we want the output of the system to be, or of the task to be. So what we want is a 3-paragraph report on emerging technologies, and we're specifying what agent we want to execute this. Now, you can imagine that maybe for a particular task, many agents could do this, but maybe you want to specify the one that you want to do this. So for example, there's lots of things I could do. I could like create a graphic for, I don't know, an event or something. But me, like Charreau Bell agent, terrible at this. You don't want her to execute this task. She's bad at it, even with generative AI. Okay. You want someone else to do this thing. We might have that task be maybe our social media marketing person, and not me. I'm terrible. Okay. So then once we have our agent, we have a task, we would create something that's called a crew. So someone asked about using LLMs as tools. We can also think about using agents as tools. We can also just think about having multiple agents that are trying to achieve the task, or achieve their individual task to result in a group task altogether, right? And so this is what the crew is. So in this crew, this is like the meta agent, where you have a set of like defined roles with goals that are trying in joint to achieve this set of tasks, and they are executing in a certain way. So someone was saying more like using an LLM as a tool, or using perhaps a hierarchical agent where one has the information about how it wants the other one to be, or the other agent to be used. So maybe that's a different architecture here than sequential. And whether we want the system to tell us everything that it ever thought in its life. Okay, so then we create our crew, and then we just start the crew. We pass in that topic thing, which goes to all of our tasks. This is what crew is. This is what you can generally think of as specifying for your system. So let's actually look even a little bit more into this. So, coming back. Oh, we can't go back. So when we were on CrewAI.com, we went to open source. After we went to open source, we're going to go to pip install CrewAI, and we're going to go into the details. Okay. Obsessed. CrewAI. So 1, if you know me, you know I love documentation. Documentation is great. You read it, you understand things, you learn how their system works, you kind of get into the minds of how they are designing their framework and how they're thinking about it, which then in turn helps you to learn how you should think about implementing the platform that you're trying to do using their stuff, right? There's also generative AI to help you with this. So things like Cursor, they can look at this entire documentation site. And if you don't want to read it, it will help you figure out how to design this. But also there's this nice Ask AI button. Well, just notice that. So 2 things to know. We've talked about this a little bit, but I mean, we've talked about this, which is we, again, have decisions about how we design our agent. We can have agents that are very agentic. They have lots of agency. And so really they have a lot of autonomy in how they decide to execute their task. They might have a narrow set of tools, but they are not so constrained in what they're able to execute and when. This would be your crew. But we also have another sort of way that we can approach designing agentic systems where we can add a little bit more nuance and user or developer imposed like control over how the system executes. So we might use the LLMs to like, it might be less agentic in the sense that, you know, like something is orchestrating when a certain tool should be called and when certain other agents should be called to do this and that and the other. And we might just say, look, we just need this LLM to do this particular thing. And we need the LLM to do this particular thing. And we need to do it in this order, but we still need the LLM to do LLM-y things. In those cases, we might use a flow. So just keep this in mind when you're designing agentic systems. Like if you have constraints that where your users or your system that you need to develop, like it needs to operate in sort of a bounded sort of behavior, especially when it comes to how things execute. You do not have to make your system fully agentic or fully like autonomous. You can impose certain kinds of structure in your agentic system so you control how things execute. So maybe at the beginning of your system, you don't just let the LLM generate anything for maybe a tool call or something like that. You just have it pick between 2 specific agents, one that does A and another agent that does B. You can't just have it do anything. So flows, again, we'll talk more about the different kinds of agentic architectures, especially for multi-agent architectures, when you need to like have more kind of narrow decision-making that needs to be implemented by the developer. You can't have like a full freedom for your system. So again, we kind of already saw this. Our crew has 1 or more agents. The agents, we also have 1 or more tasks per agent. Our tasks are related to the agent. Our agent has LLM, it has a goal. The task has a definition and outputs. We can put all of those together into a crew. We also have the additional things that we would expect. So we have access to about 1,000, not 1,000, but many different kinds of memory implemented in very different kinds of ways, depending on what you're interested in. And the system is able to execute based on that to achieve some final outcome. And again, we can do flows instead if we would like to kind of specify more clearly how we want our system to behave and control some of the control execution. So read here a little bit more. We'll just look at there about when you use one versus the other. These guides right here, super nice. Super nice. Give them a good read. Very informative about what to do and how to think about things. I'm actually going to come to agents right quick so we can talk about some of the things that we are going to design. So with agents and for tasks, we want to write really great definitions because now what we have seen is that, okay, so I will send you this. This is something we're about to go through. But what we will see is that these definitions, they are the thing that defines our agent, and the tasks, this is the thing that defines our task. The words that we have written here, like literally nothing else, except for, you know, the framework itself. But these are where we pretty much live and die on our words that we write that describe how our agents should behave and how our tasks should be executed. So because of that, we need to write really good like agent descriptions, the backstory, and the role. You can read more over this, but most of it really should be on the task. Agents, if you even think about like people doing things, the agent is just a description of what, you know, the role of the thing that should be, and the goal and kind of the backstory. But the better you describe the task, the more like people can do it. So sometimes if your task is really well defined, it really matters less what your agent, how is described versus how your task is described. And so with the tasks, I guess we can start with the agent though. So with the agents though, what we like is to have very narrow definitions of what an agent should do. And in your mind, okay, be thinking about deep research. So if you were going to implement deep research, what would you be implementing? So just be thinking about that. But what we can think about is with our agent design in this framework, you will usually be in sort of a multi-agent framework, meaning that you would have multiple agents that are good at specific things. So here, what you might have in your deep research, for example, might be your technical documentation specialist. Maybe you have a researcher, but you want to be specific about whatever agent is in that system. Writer, broad technical documentation conveys a little bit of a different kind of skill set. Because these LLMs are trained on something, and that something is things that we're used to seeing, use the things that we're used to seeing as well when you want to define their roles, and also include some more information about what they're really good at. I love the description of the purpose and motivation. This is a lot in the system prompt or in prompt engineering. These kind of suggestions that it's making to you are about prompt engineering. And when you are trying to like define the system message, particularly if you're trying to define like a kind of role, like back in the days of persona prompting in particular, these are great. These are kind of coming from that, where you're trying to just be very specific about what you want, success criteria, so we can know kind of when, what the outcome is that looks good. The backstory is also really helpful if it provides more context to the agent about how it should be moving forward and how they kind of go about certain things. Really helpful if you need to add in more information about how you want things sort of like done. These before and after, really helpful. Do take a look at these where we are seeing things that are less specific, not very detailed roles, goals, and backstories. Here we see what a good definition would look like. As we can see, the definition is going to be a good bit longer than, just something very narrow. Again, we have tasks where we want to spend a lot of our time. We want to define what the task is. We want to describe it really well. So like this, if you are just trying to write this task for like GPT-4o, just something, you might want to write something similar to how you would write it for that. But make sure that you are providing like really good detailed instructions. The more, the more, I guess the less descriptive that you have, or the less outline information that you have, the more, I don't know, variety of results that you're able to get. And the way that I tend to think about this, again, is if I have someone that I want to do something, maybe they're not overly knowledgeable about what that thing is, the better description that I can give to them, the better that they'll be able to actually do it. And so think about that. Like if you are working with like a high school student or someone who's just less familiar, then what would you give in the description to help them to actually execute that task? And also the expected output. This is if you need to have particular kinds of output for the system, you can actually specify in a type specification like framework for Python exactly the output that you want, but otherwise you can also describe this. This is also good as well. And just with your regular prompt engineering, you generally want to be providing examples if it's going to be something that the LLM would probably be less familiar with. So again, great things to read, great things to just about prompt engineering, and you'll have a chance to sort of practice with it. You'll have a chance to practice with this, hopefully. Let's see, what else did I want to show you? So, okay, let's go to agents here. So what we will do today and on Friday is we will use this through its Pythonic implementation. However, you do not have to do this at all. You can use the YAML configuration, and it is very straightforward. So for example, if you were to run this on your own computer, like you kind of just type this thing to initialize the code base. And then you really are just sitting in plain text. This is really what the agents.yaml file looks like, where you describe really straight up, you just write it. So if you're a domain expert, literally, this is your moment. This is your moment to shine, because you're going to be able to write these roles and the goals and backstories really, really well. You're going to be able to specify the details at a level which are going to be most helpful to the agentic system. And the same is true for the tasks. So this is your moment. Great moment. Okay. So the next thing is to consider the scope of things that you're able to change in your agentic system. Oh, we see that the system has changed since the last time I looked at it, which is, I wonder when that update occurred. But we see that there's lots of things that we're able to change in here. One, we are able to change this LLM, right? We could change this to be some other LLM that GPT-4, pretty expensive, or it might, is it still around? We don't even know. We can change this to 4.0 mini if we want to. If we don't have access to a function calling LLM, like if we need to use one that has been trained for tool calling, and we don't have access to one through our basic LLM here, we can add that in as well as another LLM that we can use. You see that we have access to this memory, right? So this allows us to have the long running sort of context. We have different kinds of memory that we can enable. We were talking about this max iteration. So if we get stuck in a loop, we were talking about if we wanted the LLM to be able to call other agents, right? We can set this to true, and we will allow, and that was part of allowing things to happen. And we have lots of things that we can change here to make our agent like pretty robust. So let me see, what else do I want to tell you? We'll just leave it here with that, because I see we don't really have as much time as I would like. And so what we are going to do is we're just going to pop into a notebook. I'll send you out the link for that. Is the screen sharing? Yep. Let me send you a link for that, and I'll update that into the repo. And where is the chat? And once you open that, you may need to click open in Colab button there at the top. So give me a quick thumbs up if you're able to successfully open that. All right, we are maybe great. All right, great. Okay, so there's some things that we're going to do here, and I might give you a little second to do it. But what we're going to do is we are going to use this little key over here. So you saw, right, that we need to specify an LLM. If we're specifying an LLM and it's going to be OpenAI, we're going to need an OpenAI API key. And so we are going to look at a way that we can do that in Google Colab. That is going to make that a little bit easier for us to access. So I'm going to go like through this kind of slow, and then we're also going to have like a little moment where you just let me know if you need more moments. What we're going to do is we're going to come to this little key over here. So this is already looking, I mean, you probably will not have this because there's like a million API keys right here, right? For me. But once you click on this little key, like API key, right? You're going to see this. And what you're going to do is you're going to add a new secret. And that involves just clicking add new secret. You are going to go grab your OpenAI API key and you're going to paste it here. And you are going to call it OpenAI API key. And so your OpenAI API key, it's usually going to be under platform.openai.com. So I'm going to give you a little bit of a second to populate that, and feel free to ask any questions in the chat. If you need maybe a refresher, or if it's not already here. So again, for what we're going to do, we're just going to open this up. We're going to click on this key. Once we have this key, this is showing us all of our API keys or our environment variables, whatever, that are only accessible for us in the notebooks that we select, right? We want to make our OpenAI API key. So if you need the actual like syntax of what is written, it's this. You're going to type in OpenAI. Oh, you're going to type it better than that. Oh. And then you're going to go and grab your API key and you're going to paste it here. Okay, it's not going to be this. I'm just pasting whatever I had, but that's basically what you're going to do. I'll give you a little second there. If that works, if you're able to accomplish that, just give me a quick thumbs up. Otherwise, I'll wait until I get just a few here and there. All right, I saw maybe a question. Feel free to unmute if you like, or drop some questions in the chat, whichever you like best. Move these to another screen. All right, seems like things are going well. Awesome. Okay. So something of note is that if you wanted to run this locally, you could download this and then run these lines. So if you copy and paste these in the terminal, then you could run these lines and then you would be kind of at the same place. But you would also need an OpenAI API key, and you'd have to have it in your environment. So we're going to skip that part. We're just not going to entertain that. And we're going to start running this notebook. So one, we just need to pip install stuff like we did before. So this is pip installing CrewAI. Oh boy. Yeah, with their update, this might not, we might have a little code. We might have a joint coding moment together where we debug. But here you see CrewAI tools, right? And so what this is CrewAI with additional tools added onto it. Oh, so while that's installing and thinking about that, great. You can also do this and let it run for a little bit. I'm actually going to come back to that because I think that's the main thing that I wanted to tell you. And then I immediately forgot when I came over here and started looking. So tools. Tools are like love tools, right? Because tools give you that interaction with the environment part. And the more tools that are already sort of defined, the less tools that you have to write. So I love this about Crew, that they already have a lot of tools that are already defined, but they also have integrations with other frameworks where tools are also defined. So not only would you be able to use the tools that CrewAI has implemented, but you would also be able to use the tools that LangChain has implemented, or Llama Index has implemented, or ones that you decide that you want to define. Or we will talk about MCP on Friday, but these MCP servers, which are very robust frameworks for accessing and using tools. So there are a little reorganization, okay? But these tools, these are the kinds of tools that they have available. So for example, if you want to be able to read a document and then use RAG on it, this is how you would do that. Wow, boy, that looks nice. That looks like something that I can write. That looks reasonable. That looks reasonable to be able to get a PDF that you have on your computer, and then if your LLM decides that, or if your agentic system feels like it needs to call that tool and you give it access to it, boy, it can search that specific PDF. Man, straightforward. Love it. Love to see it. Love to hear it. Love to look at it with my eyes. We also have something similar, right, with our web scraping, for example. So I know some people here have talked about web scraping. Do read the terms of use, so you don't get in any trouble. But should web scraping be available to you for what you're trying to do, you do have these tools that are just available to you. Some people might be trying to do things on GitHub exciting. You have a GitHub search tool. How would we use it? We have repo, we have access token content types. We make our tool, and we're going to pass this on to the LLM to use. This is code you look at, and it doesn't make you like terrified in your spirit. We also have a website search tool. Boys, is going to look super familiar in just a second here, where our whole goal is we are trying to conduct these semantic searches in websites. So we're going to extract information from these URLs and try and learn something from them. So we might create the tool. Any discovered websites, that's pretty cool. But for here, we might also specify the website that we want to look across. So again, if you are trying to do something specific and use a specific tool, you look at the tools that are already been created and available for you through the platform. You have YouTube, I mean, you have video, right? I mean, there's so much here that is just straight up just helpful. See whether these can do it first before you try and jump in and develop yourself, even though you should also feel free to do that if you are feeling confident. In terms of tools, you can, as you know, create your own tools. Again, generative AI will be able to help you with this, particularly if you are leveraging, for example, in Cursor, this particular API as like part of the RAG search, which is possible to specify in Cursor. For if you want to create your own tools, you kind of see what that looks like, where you kind of define what you want to pass in and the arguments and how you want it to behave. There are easier and harder and more specific ways to do certain things. But generally they have the instructions about how you can do that here. And it's if you have already written function code to make something occur, you can see where you can imagine that implementation would be straightforward in converting it into a tool for your agent to use. So don't forget description. We were just looking at the training data where it had the description. Why was that helpful? Because that is how your agent knows to use this thing. So description, always, that's new. Okay, got that? I'm just gonna run this again. Yes, so always remember that your descriptions are what is causing your LLM or your agentic system to use that specific tool. I'm just gonna hide this output here because I don't like looking at that. Okay, so now we're gonna execute some additional things. Also, it's possible that you yourself, so you could watch me implement this because I think if you have it open, you are seeing this execute. But you can also create your own copy so you have the different changes that you yourself would want to make. So now we're going to use OpenAI API key. And so it's basically saying, hey, like you didn't give me access to this. Could you give me access? We're going to say, yeah, totally fine. And we're going to do our regular Python stuff of implementing the libraries. And so if we were to go and look at their API documentation a little bit more, we would see something that looks just like this. So let's say our whole goal in life is to be able to ask questions about a website, a particular website. And we just saw that the website search tool can help us with that. So we're going to go ahead and change that. Hilariously, I have this still here. This was the first iteration where I have some handwritten notes. I love to handwrite notes inexplicably, but I have some handwritten notes and I had to take a picture of it, uploaded it, and I basically did like RAG over this picture. Very cool. Something you can also do, something you should try because Vision tool already there. Give that a try if that's something that you're interested in. But what we see is we're going to just create our tool first. We saw how we could do that with our tools. Was it this one? I don't remember. There we go. Maybe this one? Yeah, there it goes. So website search tools. We have some choices about how we want to do this, right? But we can call it like this, and we can also call it like this. So to begin with, we're just going to call it like this. So this is going to be our website search tool. We get like these, so the code that they might give you to start off with, they will give you some different, some additional code to kind of suppress some of these warnings. But this package here that's called Pydantic, this is how you can specify the specifics of what you want your output to look like. It's called like structured outputs through pydantic types. Want to learn more about that? Happy to talk more about it. But anyways, so now we've created the tools. Now we're going to create the agent. And so we can choose what kind of agent that we want to define. Maybe what I want to define, and you, again, since you have this code open, you have your API keys in there. You can choose whatever it is that you want to add here. Maybe for me, maybe what I want is an expert archivist agent, expert librarian. Yeah, because maybe we'll do a research librarian. I've recently, ever since I've been at Vanderbilt, I've come to know like a lot of librarians, and boy, did not know what librarians did. They are so cool, and they have such, man, go visit your local librarian. Don't talk too loud because you know how they feel about that. Okay, and so maybe the goal of our agent is to provide clear and obvious answers to the questions. So let's try that, because we know we're going to do web search. Maybe the web can help us. Maybe for the backstory, we just say, I don't know, what would be a good backstory? Anybody have ideas? Ooh, maybe the librarian has a particular area of expertise. That is fascinating. Huh. Okay, we'll have to try that. Okay, so we have 2 more minutes. Let me think about that so we can try that on Friday. That's fascinating. I love that. Does it depend on the website? That's a good question. So this will try to provide you the response based on these agent store for the particular website. A library in our medical school library. Interesting. That's so interesting. Try it. And then I want to hear how it goes, because that is fascinating. And I'd be interested to see the differential between writing that versus writing like something like I've written for medical text in particular. That's fascinating. Negative. Okay. Oh, no, went the wrong way. Okay, so this is what I'm gonna go with, right? And so let's run this. Let's put that in there. All right, but our agent has this, we've provided it this, right? So the role that we've written there is going to go here. We're going to give it the goal and the backstory. We are going to leave these be. What would be interesting, what we should try, if time allows, which it will not, well, maybe it will, is we should set this thing to false. See how that goes. Like we should set it to false and see what the behavior is in this case. And we can do this. So the main thing that we would like to change is this. This is something that's already been changed. I added it in there, but you can see that we've added the website search tool as a tool that this agent has access to. So let's run this as well. Great, we've made that. We can also define our task. This is the task description that has just been provided. So I wrote this, but I don't really know that I like this. What would be a better task? We're asking it, let's see, this agent, librarian. Yeah, let's just ask it. Let's see, let's just let the description be. Let's try that. So answer the question provided by the user. Okay, let's give that a try. And then expected output, a concise statement. Okay. And again, you can feel free to change this however you want to something that is of more interest to you. So let's run that one. We also make the crew here where you're seeing that we have the agent, which we call archivist agent. We have our main task here. We define this as a sequential process. Do look at the hierarchical processes because again, they allow one agent to orchestrate the others. Also in our crew, we have access to planning LLMs. So we have a planner that like starts out with some tasks or some a way to resolve or get to the goal. And then as it executes further, it updates that plan as needed. So just keep that in mind. Again, thinking about deep research. Okay. We also have other things that we can set here. Ooh. So we can make choices. So for now, let's just leave this as is. We might also choose not to have memory on this one and explore the role of memory. We might explore the role of planners, but for now, we'll just leave it as is. And then, so here goes the website link. This is going to be the provided link that we're going to pass in. And then we do need to add in one more parameter, which is going to be this user question. Oh, which is going to be so this is just a link that I added. But I'm just going to add how many credit. You can also choose your own link because maybe you're building, maybe you want to build something that interacts with the website that you have. So you can change yours here. You can change the link there. And then we have the user question and the result. So let's see how we do. So this is something here, which let's see if we can, we might be a little erroneous. I might have needed to set the actual like, we might be having a rough time. So here I might have needed to actually set the version because as we were saying, this is a different, it might be a later execution than what I had expected or a later version than I expected. We might be struggling a little bit. Yes, this is not looking good. Is anyone else's having a similar set of choices that it's making? All right, so I think that we have probably, oh, does someone just?
Yeah, I'm getting the same, like everything ran perfectly, just the last one. Yeah, the exact same error I'm getting.
Okay, maybe. So this thing right here, I'm going to try to actually see. Maybe this will help it. Nope. So often when it is, yes, so if it's, when it starts talking about Chroma is a it's a database type where you can store vector stores and other things. And the way that it uses that is for its short-term memory. Let me just check right quick that my own code is correct, because it may not be. It's possible I too have made an error. And if this isn't working today, we will just revise on Friday and see if we can help it out a little bit. Oh, this may be. This is my own user error. I think this is my own user error of nonsense, but really that really should not have had that behavior. This should be an F string. But this would not have changed that behavior. Oh, oops, I didn't mean to do that. I might just be having a little mental moment here. It's the stress of code in front of people. It's okay. It's okay. I'll look into that more. I think that needs an F string. But let me see. I'm not sure, but we will look into that more. And I think the main thing that I will send and update is the version number. And I'll update that. So yeah, so I think the way that we can work this is I will update this in the repo and I'll send you the link. And then once we get that updated, you'll know that this is the way that we want it working. But oddly enough, I'm just so fascinated by this. I think it is supposed to be an afternoon now. What have I done to this? I don't know. But anyways, the general idea is just this, where what we see is we are really able to focus on the task that we wanted to do and also the actual roles that we want to define. So on Wednesday or on Friday, we will get into this more. Specifically, we will talk about what it is to actually leverage the crew part. So with crews, you can have multiple agents and you can have multiple tasks. With your agents, we can choose how we want to orchestrate them. You also see that we have options like our hierarchical managing agent, where it can choose other agents sort of to execute instead of itself, instead of just like having this more sequentially defined approach. And we will talk a little bit more. Yeah, so we've added reasoning, we've added planning. Yeah, I just need to take a look at this. But we will look a little bit more also into flows, talking about some of the architectures that are reflected by flows. And if you're trying to design your own system, the kinds of design patterns that you might use in order to create your own flow. So that is it for today. Thank you so much for your patience. I will follow up with a change to this code and I'll push it up to the repo. And then with that, you will be able to use this all day. Also, feel free to try it on your own. I think I just am experiencing the challenges of not putting the version into your code when you write it. So let that be a lesson learned for everybody. But yes, thank you for joining us today. We're going to go into office hours. But if you have any questions, please feel free to email me. And otherwise, I will see you on Friday.